Good afternoon, guys. Yesterday we have seen the design of cylinder. We have completed some parts like definition of the cylinder. Cylinder is a mechanical device. Is used for the storing, receiving, processing, or carrying the fluids. A cylinder may be pressure vessel, storage vessel, hydraulic device, engine cylinder, or pipes. After that, we have seen the types of the cylinder. There are two types of the cylinder: thin cylinder and thick cylinder. What is meant by thin cylinder? Thin cylinder is depending upon the weather cylinder wall thickness. We have seen the ratio of the internal diameter to the thickness is greater than 20. Then the cylinder is considered to be thin cylinder. And thick cylinder, the ratio of the inner diameter to the thickness is less than 20. The cylinder is considered to the thick cylinder. Then after that we have seen the stresses in the thin cylinder. There are three stresses induced in the thin cylinder: circumferential or tangential or hoop stress. It is denoted by the sigma T. Second is a longitudinal. It is also called as a axial stress. It is denoted by the sigma L. And third is a radial stress. It is denoted by the sigma R. And we have seen the details and we'll get the some formulas. Tangential stress is equal to Pi di by 2t. And second is a longitudinal stress. Sigma L is equal to Pi di by 4t. And thickness of the cylinder we have calculated T is equal to Pi di divided by 2 sigma allowable, or we can say T is equal to Pi di divided by 2 sigma all into NL. NL is the efficiency of the longitudinal joint. Yesterday we have seen. Then after that we have seen the stresses in thin spherical vessel. Okay, there are a circumferential or tangential stresses in the thin spherical vessel. We have calculated this value. Sigma T is equal to Pi di divided by 4t. And second is a thickness of the spherical vessel. T is equal to Pi di 4 into sigma allowable. Or we can write T is equal to Pi di 4 into sigma all into NC. NC is again the efficiency of the joint. Then finally we have find out V is equal to, V means storage capacity, pi by 6 into di cube. This is given in mm. Today we will solve some numericals on the basis of that three different stresses: circumferential stress, longitudinal stress, and radial stress. We will see the first numerical. This was asked May 2018 for 9 marks. I will read the statement of the problem. A seamless cylinder of storage capacity 0.025 meter cube and made up of alloy steel 20 MO55 material is given. SUT is equal to 500 Newton per mm square is to be used to store a fluid at 15 MPa megapascal gauge pressure. The length of the cylinder is twice its inner diameter. Relation is given. Read carefully. the length of the cylinder is twice its inner diameter. If the factor of safety FOS is given 2, determine the cylinder dimension. Then which dimension we want to find out? Di is equal to inner diameter of the cylinder, length of the cylinder and thickness of the cylinder we want to find out. First we'll write the what is the given data. Read the problem statement carefully. Storage capacity V value is given 0.025 meter cube. We want to convert into the cube because all these values are given in cube. 0.025 into 10 raised to 9 cube I have converted. Then second, ultimate strength SUT is given 500 Newton per square. Then gauge pressure means inside pressure in the cylinder is given 15 megapascal. Okay, you know the relation between megapascal and Newton per square. 1 megapascal is equal to 1 Newton per square. Then we'll keep as it is this value 15 Newton per square. Then length L is equal to 2 di. The relation is given. The length of the cylinder is twice. Length of the cylinder is twice its inner diameter. Then we can create the relation L is equal to 2 di. And finally factor of safety is given. It is denoted by N suffix F is equal to 2. Then see allowable tensile stress. You know how to calculate that allowable tensile stress. Sigma all is equal to, you have given the SUT value, ultimate strength is given, divided by factor of safety. Ultimate tensile stress is 500 divided by 2, you will get the 250 Newton per square. Okay, I will move this screen, then you can easily see here. Okay, then see inner diameter and length of the cylinder. Okay, how to calculate the inner diameter and length of the cylinder. See inner diameter it is denoted by the di. Okay, you know the storage formula, storage capacity V is equal to pi by 4 into di square, means area into length. You will get the meter cube, means volume of that cylinder. We want to calculate the storage capacity. Then you should put the value of V 0.025 into 10 raised to 9 is equal to pi by 4 into di square into L is equal to, we know the relation, L is equal to 2 di. If you are solving this then you will get pi by 2 into di cube, pi by 2 into di cube. Then next see, then we will solve di cube is equal to, you will get 0.025 into 10 raised to 9 into 2 divided by pi. Di is equal to, if you have calculate, then you will get the 251.54 mm, or approximately we can write 255 mm. We know that the relation L is equal to 2 di is equal to 2 into 255, means you will get the length dimension 510 mm. We got the both answer, and remaining is a thickness. How to calculate the thickness of the cylinder? Assuming first the cylinder as a thin cylinder. Okay, you should assume the given cylinder is a thin cylinder. T is equal to pi di divided by 2 sigma all into NL is equal to, put the value, pi is equal to 15 into di 255 divided by 2 into sigma all 250 into L. NL is the efficiency of the longitudinal joint. This efficiency is not given in your numerical, then assume the value of that efficiency is equal to 1. Remember that, very important. Don't write any value, only write 1. Then you will get the T is equal to 7.65 mm or 8 mm. This is the third answer. Now we want to the check our assumption is correct or not. How to check that assumption is correct or not? With the help of our definition of the thin cylinder. The ratio of di by t is greater than 20 or not. We want to the check. We have both value di and t value. We will put and find out the ratio. 31.87 is greater than 20. Therefore, the initial assumption that the cylinder is a thin cylinder is correct. Okay, all of you getting how to solve the given numerical with the help of thin cylinder formulas. Then we'll see the one more numerical. Check that this was asked December 16 for 5 marks. An air receiver consists of a cylindrical shell of 500 mm inner diameter. It is closed by the hemispherical end. Which end is given? Hemispherical end is given. You should know the formula is related to the hemispherical end. The operating pressure is limited, okay, not to exceed than 3 MPa operating pressure. The cylinder is made up of steel Fe ferrous E200 and factor of safety is 2.5, treating the reservoir as a thin cylinder and neglecting the effect of welded joint. Determine the thickness of the cylinder shell and the thickness of the hemispherical end. Okay, we want to calculate that two value. See, read the problem carefully and write down the given data. The inner diameter is given. It is denoted by di is equal to 500 mm. Okay, then operating pressure is not to exceed than pi is given 3 MPa. I have already told the 1 megapascal is equal to 1 Newton per mm square. Then yield strength is given. SYT is given 200 Newton per mm square and factor of safety is given. It is denoted by NF 2.5. Then we want to calculate the thickness of the cylindrical shell and thickness of the hemispherical end. It is denoted by T suffix S is equal to how much and T suffix H is equal to how much. Here we will consider the NL is equal to NC is equal to 1. Means efficiency of the joint we will consider the 1. This efficiency is not given. Okay, I will draw here one figure. See that figure. There are two hemispherical end is joint with shell. Okay, then thickness of the hemispherical end I have considered here TH and thickness of the shell I have considered the TS and the inner diameter of the shell is denoted by the DI and the radius of that hemispherical end I have write here di by 2. Then see, you know the formula. With the help of the formula we can calculate thickness of the shell. Before going on the thickness of the shell, we want to calculate the sigma allowable. Okay, sigma allowable, how to calculate? Sigma allowable is equal to SYT divided by NF. Remember that if you have given the factor of safety value, then you should calculate the sigma allowable, means allowable stress. Definitely you have to calculate first sigma allowable value. 200 divided by 2.5, you will get the 80 Newton per mm square. And second is a thickness of the shell. How to calculate the thickness of the shell? It is denoted by TS. Again same formula, last numerical we have seen, pi di divided by 2 sigma allowable into NL. Okay, put the value of pi di 3 into 500 divided by 2 into 80 into 1. You will get TS is equal to 9.374 mm, or we can convert into the 10 mm next digit. Okay, this is the first answer. Thickness of the hemispherical end, how to calculate that? we have seen how to calculate the thickness of the hemispherical end. TH is equal to pi di divided by 4 into sigma all into nc is equal to again 3 into 500 divided by 4 into 80 into 1. You will get the 4.687 mm. You can convert into the next digit 5 mm. Means we have calculate here both thickness. Okay, thickness of the cell and thickness of the hemispherical end. Okay, all of you getting how to calculate? This type of question will be asked for the end SEM examination. We have seen the 9 marks question, 5 marks question. The next question we'll see, this question will ask for the 10 marks. This is important. See what is given. A reservoir of the reciprocating compressor consists of a cylindrical cell of 1000 mm length and 500 inner diameter. Okay, cylinder length is given 1000 mm and inner diameter is given 500 mm. It is closed by the hemispherical end. This is important statement. It is closed by the hemispherical end. You should use the formulas related to the hemispherical end. The air pressure is limited to the 40 bar. Air pressure is given PI 40 bar. You know the relation bar and Newton per meter square. 1 bar is equal to 10 raised to 5 Newton per meter square. Okay, then we can convert 40 bar into the Newton per meter square. 40 into 10 raised to 5 Newton per meter square. Again another value is given in mm. That's why we want to convert this value in Newton per mm square. Then you can convert 4 into 9 Newton per mm square. 4 Newton per mm square. Then next see the efficiency of the welded joint for the cell and ends. Both efficiency are given. Don't assume here efficiency. Both efficiency are given. Cell efficiency and end efficiency. NL is equal to 0.9 and C is equal to 0.8. And last, allowable tensile stress is given 80 Newton per mm square. In this numerical, check that you don't given the factor of safety. Directly they have given the allowable tensile stress. That's why they are not given the yield strength or ultimate strength. Directly that value is given, sigma all is equal to 80 Newton per mm square. And what we want to calculate? Thickness of the cylinder cell, TS, then thickness of the hemispherical end, TH, and the storage capacity of the receiver. Storage capacity, it is denoted by the V. Okay, last numerical we have calculated the both value. Only new value is the storage capacity of the receiver. See, I have drawn here one diagram. There are two hemispherical end is connected to the cell. Okay, LS is the length of the cell, TS is the thickness of the cell, then di by 2 is the radius of the hemispherical end, TH is the thickness of the hemispherical end. Okay, and I have divided this cell into 3 different parts. First is a V1, second is a V2, and third is a V3. Because having the 3 different shapes, okay, 2 hemispherical end and one is the cell is there. That's why we want to calculate the capacity, storage capacity. Means we want to calculate the volume of that cell. Okay, first we want to assuming the reservoir as a thin cylinder. Okay, then what we want to calculate? First we want to calculate the thickness of cell. You know the formula, TS is equal to pi di divided by 2 sigma all NL. Put the value and you will get the TS is equal to 14 mm. Last numerical we have seen same things. Then second, thickness of the hemispherical end, TH is equal to pi di 4 sigma all into NC. Here you have given the NL and NC value. put the both value in the thickness of the cell and thickness of the hemispherical end. You will get the 8 mm th. Then third is the important part, storage capacity. How to calculate the storage capacity of the cylinder? Yes, V is equal to volume of the first hemispherical end plus volume of the cell, and third is a volume of the second hemispherical end. You know how to calculate the volume. Volume means what? Area into length. Okay, area into length of that component. Okay, or LBT dimension. We are consider the LBT dimension. Then what is the volume of the hemispherical end? First, pi by 12 into di cube. Remember that formula. Pi by 12 into di cube plus second V2 is equal to pi by 4 into di square. Area into length of that cell plus pi by 12 into di cube. Then see, first and V1 and V3 are same. I will write again, repeat that equation, rewrite that equation. Pi by 4 into di square ls, this V2 as it is, plus first and third means plus 2 into pi by 12 into di cube. Then if you have solved that, 2 divided by 12, you will get the 6, pi by 6 di cube. Then pi by 4, put the value, di is equal to 500 square into length of the cell is given 1000 plus pi by 6 into di cube, 500 cube, is equal to, you will get the 0.2617 into 10 raised to 9 mm cube. How to convert into meter cube? Again you should divide it by 10 raised to 9 for that mm cube value. Then you will get the storage capacity, V is equal to 0.2617 meter cube. Okay, all of you getting how to calculate the storage capacity of the given receiver. Okay, now we want to the check our initial assumption is correct or not. How to check? Again, with the help of definition of thin cylinder. Di by ts is equal to, we have both value, 500 divided by 14 is equal to 35.71 is greater than 20. Also di by th, th is the thickness of the hemispherical end. 500 divided by it will get 62.5 is greater than 20. Hence initial assumption is correct. Okay, after completion or finding the value of ts or th or t value, you should check the initial assumption is correct or not. Okay, then you will get the full marks. Okay student, today we'll stop here. Next lecture we have completed in this 2 lectures thin cylinder part, then remaining part is a thick cylinder. Okay, we will complete that thick cylinder part in the next lecture, theory as well as numerical. Thank you.